Hello, everybody, and welcome to another OKD Working Group briefing on some of the exciting new things that we're doing to make OKD work in lots of different platforms. Today, we're going to talk about the CoreOS build pipeline using Tekton. So you've heard us talk about CentOS Stream CoreOS, and this is a project that Luigi and a number of other folks, including Christian Glombek, Alexandro, Sharon, a whole bunch of folks in Red Hat have been working on diligently to get an MVP out for us all in the working group to test and deploy. And I think it's really interesting because it's showcasing sort of a tectonic shift, shall we say, to Tekton and a more flexible build pipeline approach that we're working on with the OKD and the OKD Streams initiative. So I'm going to get Luigi and Christian to introduce themselves, and then Luigi's going to walk us through this, and we're going to have some Q&A, and we'll come back and talk about some of the next steps after that, after we're done. So Luigi, take it away, and thank you both for being here today.
Thanks for having us, Diane. It's an absolute pleasure. So yeah, my name is Luigi. I work on the customer-focused engineering team, and we were tasked to help out with the OKD build pipelines. So, the ask was basically to get a sort of pipeline going, and to also have it facing for the community. So the natural selection, the natural choice really was Tekton. Tekton is really a open source Kubernetes native CI/CD build platform that's based on containers that are totally configurable. You can basically, the great thing about Tekton is its flexibility. It has notions of tasks, pipelines and pipeline runs, which we'll just go through later. So basically what we wanted was to get a pipeline that you could use to build locally, as well as use it on a dedicated OpenShift platform or a Kubernetes sort of installation with multiple nodes that you could really get some real hardware behind your pipeline. So that was the main requirement. And just to give you an overview of the architecture. Basically, I don't know if you can see. Yeah. So basically, the real core of the pipeline are the actual tasks over here. So what I've tried to do is just show you a very high level overview. So basically, you'll have a notion of a task. Task could, basically it'll launch a container, a pod. Within that pod, you'll have containers or several containers, and there you can embed a script. You could do simple bash scripts, or you could do some real funky things with other different languages. So we based ours basically using bash script, and we'll have on some of them enable Go, so you could actually run Go code natively.
Luigi, before you run to the next slide, let me quickly jump in here and elaborate a little more on the requirements we have for running the pipeline. So what you see here, yes, also is on the nodes, or connected to the nodes, is the KVM device plugin. And so we run the CoreOS builds, and in this case the CentOS Stream CoreOS builds. We can run them in any environment, as you have mentioned. One requirement for doing that is virtualization, KVM virtualization, to be enabled on the platform. And we do that both in, for example, locally kind Kubernetes in Docker or Kubernetes in Podman cluster, or on an OpenShift cluster, or on a standard Kubernetes cluster. We do that enablement of KVM with the KVM device plugin, which is also being used, for example, by the KubeVirt initiative in a similar manner. And that just exposes that KVM device to the pods that actually run, where the actual builds run. And so, yeah, there is CoreOS assembler, that is the build tool for building CoreOS, and we run that CoreOS assembler inside Tecton tasks. Yeah. And yeah, that's it from me. Back to you, Luigi.
Yeah. Okay. Cool. No. Good one. So basically, what I've shown you is, in order for that to happen and I've specifically labeled this as operate first here at the top. So this is a OpenShift dedicated cluster. And so what you'll see here is a machine config and machine config that help us, as Christian mentioned, deploy the KVM device plugin and allow for nested virtualization on each node. So I think on the cluster there's something like 26 nodes, and obviously we can't have our KVM plugin on every single node. So we have a notion of a daemon set that will deploy the KVM device plugin on specific nodes, and then the machine config will also have labeled nodes. So later on in the demo, when I'll show you the web front end for Operate First, we'll show you we'll go into the KVM plugin and the daemon set that's deployed. So it just makes it more efficient and effective. We don't have to overload the actual Operate First cluster. So basically, together with the tasks and pipelines, so basically a pipeline will consist of several tasks. So you could have, say, like 10 tasks, and in a pipeline you can say, I only want to use task 1, 3, and 9, or something like that. So it gives you great flexibility to set up and deploy different pipelines. And then you have the notion of a pipeline run, and in that pipeline run you will set specific parameters, and you can tell the pipeline run, well, run this pipeline with X parameters, or run this pipeline with Y parameters. So you can see here there is great flexibility, and together with that we have RBAC, role-based access control, and we'll have service accounts and secrets tied to the actual pipelines. What I've done here is just to show you an overview of the actual layout. We make use of customization, which is a great little plugin. So you could basically use your kubectl to deploy this whole application, and instead of you say kubectl apply or kubectl create -f, you use the -k directive, and it will then call customization. And customization will then look into each folder and see if there's another customization file, and basically load whatever that second or third or fourth or embedded customization file says. So at the bottom here, you can see we've had, and Christian will go into more of the COSA, which is the core assembler tasks, and sort of explain more about them. But we have a couple of tasks that we're going to be using. We start off with the RPM artifact, then we'll do a COSA init, then we'll do a build, and then add all on the different other tasks as we go along. So what I'm going to do.
Let me again just very quickly jump in here. The great thing about using essentially GitOps here with Customize is all of the complexity of the infrastructure setup here, that enabling KVM and everything. We can set up all of that in a cluster with one command, which is kubectl apply -k, and then you essentially choose one of the overlays for your environment. So for example, in a kind cluster, you would just apply the local overlay, and it'll set up everything for you. The KVM device plugin and everything, nested will be enabled in your, or virtualization, KVM virtualization will be enabled in your local kind cluster with just one command, and it'll create all the tasks for you, and then it's just up to you to create one pipeline run, and your pipeline with the default config will be running. So it's really, really nice to have all of this in just a Git repository, apply it, run it, and it'll run in essentially 1 minute. yeah, no setup time essentially for first time users here. It's really great to do it that way.
Yeah. So what I was going to actually show in the demo, what I'll do is I'm going to escape from the actual presentation and go to our, but it's basically the GitHub OKD project, OKD CoreOS pipeline. That's the name of the project. Cool. So what I'm going to do, obviously I've actually cloned this repo on my local machine, and so what I'm going to be doing is actually deploying this here on a local instance on my kind cluster. So what I'll just do this quickly is just do a K get nodes just to show you that I'm on a kind cluster. I have one node. Is this font? Can you guys see it okay?
Yes, I think I can read it all right.
Should I just go a little? Let me just see. I think I've reached my font limit here. Yeah, I've reached my font limit. Okay, so we'll just have to bear with me. So, and then we can have a look here. I'll go run the actual install of Tekton. So Tekton is going to basically it will. Oh, sorry, was this?
I think the link you copied isn't. There's a part missing at the end.
Go back.
It's not the full URL. It's not the full URL.
Cool. Thank you. It helps.
The .yaml was missing. All right.
Yeah. Okay.
Oh yeah, I forgot earlier. One thing you have to do before running the pipeline is actually installing Tekton on your fresh kind cluster.
Yes. So what I've done now is I've actually gone ahead and installed Tekton, and if we'll have a look, you'll see the Tekton pipelines namespace has been installed, and then we'll just check to see if all the artifacts have actually deployed. And we can see over here, so we have Tekton basically being deployed. It's going to be deploying some controllers, so a webhook, and some services. It does the deployment. And so while that's going on ahead, I'll do the second part, is actually go ahead and deploy our application that Christian mentioned earlier on. If you notice, it has the kubectl apply -k directive or flag, and it's going to deploy we have a notion of overlays. So you can have an overlay. We have two overlays for now, one for local development and one for operate first. So I'll go ahead and deploy that. It goes ahead and then we'll configure the application, and I'll go have a look. We'll look at the namespace, and there it's deployed. Let's have a look. Get all -n, and it will deploy for us the it will deploy all the relevant pods plus the actual daemon set for the device plugin, and you can see there's a device plugin that's installed. And I've cheated a bit. I've already done a pipeline run, and you can see those have completed. But so basically now we're in a place where we can actually go and have a look. We can say, okay, list all the pipelines in this namespace. Let me. And I've done a CoreOS build that has succeeded. And what we can do quickly is just have a look at the pipeline run, which is this one here, and we can actually just say we want to describe this pipeline run. It'll give us an overview of what actually happened and what tasks were run.
And what you're doing now, and what you're doing now is using the TKN Tecton CLI, which has these convenience, convenience functions.
Yes. Thanks for bringing that up. I actually forgot. You need to install. So over and above installing the Tecton pipeline, you would need to install the client.
It's not a requirement for. It's not a requirement for running the pipelines, but it'll make your things easier to get the logs from the right pods and things like that. So it's really definitely recommended to also install the TKN CLI.
Absolutely. And if you can see here, it actually tells you what parameters are going to be used in the pipeline run that we are going to be initiating. So to initiate this, it's simply doing something like create minus F, and then we have pipeline runs already set up for you in our overlays. So there's a pipeline overlays local pipeline runs, and we'll do the pipeline run for the build, and that's it. That's as easy as it gets. Your pipeline run has started. What I'll do is just show you. I'll do a pipeline run list, and we should have a pipeline run that has been initiated. Sorry, my bad. There we go. Okay, and then we should have a pipeline run that's just started. So what we can do now is just go ahead and we can follow this by tailing the log, and we can have a look at the actual logs for each build. It's slow.
Might take a while till it starts logging.
Yeah. But what I can do while this is running in the background, we can come back to that. I wanted to just show you the web front end for our OKD build. Let me see. I think this is also, it needs to be expanded a bit. Is that okay? Can you see this okay, guys?
Yep, it looks great.
So,
yep.
So here we have the actual KVM device plugin namespace, and you can see that with our machine config and machine config pools, it is deployed, and with the daemon set that was used, we are running these pods for the plugin. All this really does, and Christian, you can explain exactly the details there for the way that the dev KVM is used for us to speed up, because there's a nested virtualization. There's a QEMU and I think other stuff that gets run in the COSA build.
So yeah,
you can see that
COSA is the CoreOS assembler. That is the tool to build CoreOS, essentially, any kind of flavor. And that uses a VM to actually do those builds. So we need virtualization capabilities exposed to the pod where that build runs. And that KVM device plugin essentially does that. It plumbs through the KVM device from the host into the pod, makes it available inside the pod to the workloads running there.
Yeah. And you can see there we have 3 nodes basically, OCT 0301, 03, and 00. And so those are the compute nodes that our workloads are going to be running on. So if we go back And this is operate first. What we have here, we've actually also had a couple of runs. We've had 1 or 2 failures. But the notion here is for the pipeline runs is just a great visual to show you exactly what the pipelines are doing. And we can have a look here. We had a look at this build. It lists the actual tasks that were run. If we go back to the pipeline run itself, over here, you can have a look at each one of the logs. You can see what happens with the artifact copy.
And very quickly to again elaborate, the artifacts copy step, the RPM artifacts copy step here. What we're doing is we actually have the OpenShift client and the OpenShift Hypercube RPMs. They are part of the CentOS Stream CoreOS, and they are being built in our OKD build system, which is a prowl cluster that we also use as CI for OpenShift. And in order to pull those, because we don't have them in Fedora or in CentOS repositories yet, so we kind of pull them from our CI and build system. And because we have this artifacts image where these RPMs are shipped, so in order to extract them and make them available to the real CoreOS assembler compose that we're running, we do this kind of preparation step here to download the RPMs from the RPM artifacts image.
Yeah,
and then we
I highlighted for the client, for the and for the Hypercube as well. And then I've just quickly wanted to just show the different logs that we can actually go view the logs at any given time. There's quite a lot of logs, but the great thing that what we never showed in the actual overview of the architecture is this notion of a persistent volume claim. So what we do is we mount the pipelines, we mount the volumes in a pipeline so that we can access all the artifacts that actually get built. So your ISO image, at the end we'll also have a container. A container gets pushed to Quay so that we have it on a registry. So this is really neat, so that we can, once the jobs have completed, we can go and access these PVs and extract all the relevant artifacts.
In terms of Tecton, we use that PDC as a workspace, and a workspace is accessible to all the tasks within a pipeline. So we can have one task initializing our the config repository where the manifests that define the operating system live, and then we have another step that also has access to that same file system within the workspace to do the build. It'll do just the OS tree build in the first step, store it in the workspace, and then in another step, in another task, we still have access to that same workspace where we then have the artifact from the previous step, as well as the metadata JSON that is generated by our CoreOS assembler. So we can kind of add up without having to each time create a new PVC for each step or for each task. We have one pipeline that has access to the same file system all the time. That is really neat.
Yeah.
In terms of Tecton, this is a workspace. We're using the as a workspace or mounting it at the workspace.
Yeah, that's it. So we, as indicated, the good one there, Christian. So the workspace is available to all tasks across all the runs, and then this workspace is actually also, if you have a look in the pipeline run, it gets initiated. I don't know if we can show it here, but in the YAML, let's see. We create a template Let me just see if I can find that.
Right. In the pipeline definition, we only specify that there is a workspace, and then in the actual pipeline run, we further configure what that workspace, how that workspace is created. It could be an empty dir, which is what we do for the local runs in the kind cluster, or it could be a PVC on a real OpenShift cluster like here.
Yeah. So great point. Because over here you can see we've in the pipeline run we've specified that this shared workspace must use a volume claim template. We tell it what the access mode is and what storage to use, and then the provisioner within Operate First will pick this up and automatically create that PV for us and then start the task. So it does this all automatically. We just have to specify that.
And what we do here is we use a volume claim template. That means we actually create a new volume, new PVC. We could also reuse an existing PVC by specifying that specifically. So we could kind of over time with different pipeline runs still work on the same file system. Right now, we're using a volume claim template to set up a new PVC, but we could also reuse it.
Yeah, but by specifying this name here, and instead of saying volume claim template, you just say, use this claim name when I run my pipeline run, and it will reuse this PVC that's already been.
And maybe, Luigi, maybe you could go into the pipelines and kind of start a new pipeline through the UI. There's nice. Actually, on the OpenShift cluster on Operate First, the pipelines section on the resources. Oh, and we are having logs now.
Yeah. So
if you go to the right side and click on the three dots next to the build on the build line.
On the build line, sorry.
On the very yes, and then. Below that, and we can do that, click on Start, and it'll take you to a very nice UI that lets you define all the parameters. And if you scroll all the way down, it'll let you also define what to mount as a workspace here. So we can either do a persistent volume claim, which would be an existing volume, or we use what we did there, a volume claim template to create a new one. Or the empty directory is what we do locally. So you can also trigger these pipeline runs through the OpenShift UI here.
Yeah,
but again, that's not necessary. You can do all of that just by applying the YAML as you've shown in your local cluster.
Yeah. So I wanted to just jump back to our logs here, just to show you that our build is still running. On our local cluster. I mean, I know it's very difficult to see here, but what is so nice is that the Tecton command line gives you the notion of different colors for different tasks. So what I could do here is just break this and just show you the one that succeeded. We'll get the notion of different colors so that you can actually view the logs better, So let's just have a look here. And we can do more. Okay, that was me.
Without more, I think you'll.
Yeah, that's me. Sorry, yeah. We have to do it this way.
This is a very long. Well, this task has a.
There's a ton of stuff happening. But you can see basically here, the first task is in green, the copy RPMS, then the init. And then it does a couple of things, and then it does the fetch and build, which is nice. It gives you a great separation of concerns regarding the logs that you can use for fairly debugging and looking at different places in your logs. I don't know. So for the actual demo, I think that's about it that we have to show. What I can do is just share the actual links, some useful links that we have that you guys could go reference. The Git account is, and I think Diane will have the slide deck available for the guys. Hey?
Yep.
Yeah. So you could go there. PRs are welcome. I mean, we're having this. This is community facing. We want guys to get involved and sort of get stuck in and play around and use it on your local kind. So we have tested. I just have to say this: we've tested this on an OKD single node cluster. We've tested on kind, and I've tested on a vanilla Kubernetes. It was a 5-node vanilla Kubernetes cluster, and then obviously OpenShift. We still have to try Microshift. I think, Christian, that might be next.
Indeed, yes.
Yeah,
That would be great. Yeah.
Yeah.
And again, right now this is very much geared towards building CentOS Stream CoreOS. As we are kind of maturing this pipeline, it'll also be more agnostic and more generic. And in the future, we'll be able to, for example, rebuild Fedora CoreOS or just build your own OS with your own manifest list or your own manifest of RPMs. This is really, and we already have internal customer interest here from colleagues who want to build their own OKD stream just to test out new features and have essentially a specific build for their feature where they can just cut out all the things they don't need and just build what they need. And this is essentially one part of the future OKD streams pipeline, which will combine this base OKD CoreOS pipeline with another pipeline that'll then build the images that make up the components of the cluster part. So this builds the base operating system, and then which is the OKD CoreOS pipeline, and then there's another pipeline in that same OKD project GitHub organization that is actually that can be used to build all the images that are in an OKD payload. So what we really want to look at eventually is making it really easy for anybody to build their own OKD payloads. And we have 2 officially supported streams, or we will have. Currently, we only have one, which is OKD on FCOS, OKD on Fedora CoreOS. Soon, we will have a second one, which is OKD on CentOS Stream, which is what this pipeline builds now.
Yeah.
And in the future, anybody will be able to create their own stream. I think that is one of the key takeaways here. You can build your own very much bespoke thing for your purposes, your own operating system, your own base operating system with this pipeline, and then with the other pipeline, the payload components.
Yeah. So this is one of those things that's over time, having been with the OpenShift and OCP and all the evolutions, we've always done these like dev previews, which have been, let's get it out with the release. This is some crazy, wonderful new feature either a customer or an engineer or a community member wants to test and play with. And in my mind, what this Streams project lets us do is gives us a lot more freedom to innovate, whether it's engineering within Red Hat or engineering resources outside of Red Hat, both at the OS level and at the OCP OKD level too. So, you mentioned earlier, there's a lot of internal clients for this at Red Hat. So there's a lot of demand internally to use this, which is great because that means we have lots of eyeballs on it too. But we've heard from outside of Red Hat, there's lots of interest in custom OKD builds. And this is this is, I think, why this project is so exciting, and this paradigm shift to focusing on Tecton pipelines and creating things that the community can build and fork and use to create OKDs for whatever bespoke purpose they have. I think you touched on something also, Christian. We can continue to have the Fedora CoreOS build of OKD and do that because there's some bespoke things for the Fedora thing. But the CoreOS layering, you touched on that a little bit. Can you talk a little bit on the kind of freedom that gives us and how this showcases some of that?
Absolutely. So what this pipeline does that we just saw, this runs CoreOS Assembler, and CoreOS Assembler is already the tool that is used to build Fedora CoreOS. The Fedora CoreOS, that the official Fedora CoreOS release, isn't quite ready to run Kubernetes on it. It doesn't have the dependencies needed to do that and to run OKD. So what we do, and what is now possible, and it will be possible with, what we will be using with OKD 4.12 and going forward from there, is we will take the official Fedora CoreOS release, and then using CoreOS layering, we will change that base a little bit. We will add on top a few changes and a few RPMs that we need as dependencies for running OKD, the cluster, on top of that base operating system. And the great thing about CoreOS layering is that it just works like any container build you're used to. You have a Docker file or a container file where you just install more packages using RPM OS tree. So you have a from directive importing Fedora CoreOS, because Fedora CoreOS is now available as a native container image. You import that through the from directive, and then you just RPM OS tree install a couple of more RPMs on it, and then you commit that to a new derived container image. And Fedora CoreOS layering, the generic one, is really useful in that sense. You can manipulate the base operating system. You have a container image that wraps the entire operating system. It has everything in it, the bootloader, everything. It's the whole operating system, but it's shipped as a container image. And there is a whole bunch of benefits to this. We can use it, manipulate it like in a container build, what most developers are nowadays used to, but we can also distribute it through standard container registries. And I think that's another great benefit here. We can essentially ship a bootable image as a container image, which makes this really much easier to do than uploading different boot images for each platform. RPM OS tree now also supports creating these container images and rebasing to these container images. We haven't talked a lot about RPM OS tree today. Just to very quickly note, the CoreOS assembler essentially wraps RPM OS tree and runs RPM OS tree compose, which is the command to create that operating system. And this is what we run. What we run in Tecton. I did want to do a shout out.
We're going to go even deeper with Colin Walters at the OpenShift Commons gathering coming up. And he's going to give us a lightning talk, which I think will be amazing to get him to say anything in less than 10 minutes. But however, he's going to go dive deep on that, and we'll have a recording that dives deep on CoreOS layering for you all shortly, sometime in early October. But the other thing, I think, and I just want to make sure that everybody's clear on that, this is the CoreOS pipeline. So the next thing that Christian and Luigi and everybody has to do is it has to tuck this into the existing PROW pipeline to do all the testing and everything. So if maybe you could talk a little bit about that, because this is part of the OKD Working Group initiative. but there's this whole other thing that has to happen now to get the MVP out the door. So maybe a little bit of a update on what the status is and when we can, and how that's all going to work.
Absolutely. So currently, and as you may know, we have the OKD Pro instance, which is it's also used as the OpenShift CI system. So we use that as the build system. It's really the OKD build system that we use as a CI for OpenShift as well. But from experience, we know that Pro is a bit difficult to work with, and it's not a system that has a big community. So it may be hard to find resources on how to set it up, how to use it. It is a very powerful system, but it's also not the easiest to work with. So that's one of the reasons we chose to implement this pipeline with Tekton primitives, because we think there is more. The community is already there, and we will fit right in there. And what we will be able to do with this is we will be using Tekton tasks and pipelines, and we will integrate that with Pro at first, and we may call Tekton pipeline runs from within Pro, but eventually we will want to migrate over to more Tekton native setup where most or more of the OKD build system is Tekton instead of Pro. So and because we think that it is more composable, more obvious to work with. You have your tasks and steps as the primitives, and then you can create your pipelines as you wish. You can mix and match the different tasks, put them together in a pipeline, and run them. And it's easier to grasp, and the learning curve is much nicer there. So our goal really is to make Tekton into the future OKD build system, and move away from Pro over time.
Mm-hmm. The nice thing I was just going to mention on that is that the entry into getting started is so minimal, because like we've shown you, just with Kind, once you've installed Kind, I think I issued 3 commands to install Tekton, install our pipeline, and a command to actually start the pipeline run. And you're up and running, and then basically you can go ahead and change the actual scripts within each task. So it is extremely flexible, extremely easy and run. And so I think this is what we're hoping, that because of that, the sort of momentum and adoption, whatever, of using the pipelines is going to take hold because of the ease of use. And that's a good point you bring there, Christian.
Because we've seen people building OKD for bespoke versions of OpenStack and other things. And so I think the community's hope in the OKD community is, once we have these Tekton pipelines, people will either leverage the Operate First community as well as we are, or use these Tekton pipelines locally or in their own on their own clouds, and start giving us a whole bunch of feedback on OKD and things that we can add in on top of OKD to start innovating in the upstream, as opposed to waiting for things to trickle down from OCP. And this opens up so many possibilities, and in some ways gets rid of what I would call some technical debt that we probably have in the engineering departments across Red Hat, trying to keep these dev preview things going on beyond just dev preview. So I'm really excited about the possibility for driving more innovation into OKD and OCP and Kubernetes and all of the other related folks, including Tekton, because it's wonderful to be able to collaborate with yet another community to make this happen. So we're looking forward to it.
Absolutely. And one thing I wanted to say is stay tuned for our SCOS MVP, which is the OKD on CentOS Stream CoreOS minimum viable product. So our kind of first version to prove that it works is coming soon. Stay tuned for that. We will also be releasing this pipeline and the other pipelines from our OKD project GitHub organization to Tecton Hub in order to make those available to a broader audience and gather more feedback, really. And obviously, PRs are welcome. If you see something that isn't ideal or you want another task that does something related, please feel free to open a pull request. We will be very happy to take a look at it. If you already have Tecton, a lot of Tecton experience, please also just review the code we've already put in the repositories. We were very excited to finally get to use Tecton for work. But at least I haven't had a lot of experience before starting this MVP.
Yeah.
We'd be very glad to take your reviews on what we have.
Yeah, absolutely.
Yeah, absolutely. So, and the OKD Working Group meets on Tuesdays on a regular cadence. You can get that from the Fedora calendar. And you can find us on Slack as well in the Kubernetes Slack channels for its OpenShift users, I believe is the correct channel in the Kubernetes Slack channel. So if you're looking for us there, and we'll probably start popping into Tecton Slack channels or IRC or whatever the Tecton community is using these days. But we're really excited to do this and to bring this to the forefront. And I can't thank Luigi and his team and Zach and Michelle Krecki and everybody else on the customer-facing engineering teams for all the work that they've done here, and for Neil Gompa and Jamie and a bazillion other people in the OKD Working Group for making this collaboration happen. And there's also another whole group to thank, the CentOS Cloud SIG out there for taking this project on with us. And we're looking forward to all this wonderful cross-community collaboration to seed some future innovations and to really streamline the build processes for OKD and make it available everywhere. So Luigi, Christian, thank you again for your time. This is just one of those projects that highlights why open source rocks so much. And
no, absolute pleasure. We had so much fun doing this.
Awesome. We love the word fun when it's tied to work.
Yeah.
All right. Take care, guys. Thanks so much.
Cool. Thanks.
Thank you.
Cheers.
Bye-bye.
Bye.